This is a WEG CFW100 Inverter Drive, and this is a 3-phase electric motor. In this video, I'm going to show you how to correctly set up the CFW100 to start, stop, and set the direction of rotation in local control. Hello, I'm Simon from the Inverter Drive Supermarket, and this is part 1 in our video series covering the CFW100 Inverter Drive from Brazilian manufacturer WEG. This video is loosely based on our free Easy Start guide, which can be downloaded from our website if you want something to refer to. The drive is supplied with a quick installation guide which also covers some of the material in this video. The first thing we will do is fit the optional EMC filter, as the CFW100 doesn't include one as standard. The filter is required for EMC compliance and is a key part of the installation, protecting other equipment from electromagnetic interference that may be created by the inverter during normal operation. The EMC filter is available to order from our website and is fitted between the supply and inverter. To install it, first ensure the supply terminals on the CFW100 are loosened. Then hold the inverter and upper part of the filter together before clipping both to the main body of the filter at the rear like this. Finally, tighten the CFW100 supply terminals. I find it's better to fit it this way, as it can be difficult to attach the upper part of the filter if the main body is already in place. Now the EMC filter is fitted, we can install the inverter on a standard 35mm DIN rail. This one is 7.5mm deep, in case you are wondering. This is a 230 volt inverter, and the supply can either be line to neutral or 230 volt line to line. The inverter will convert this single phase input to a 230 volt 3-phase output. WEG recommend that the supply to the inverter is fused. The manual states that a 20 amp semiconductor type AR fuse is required for this particular rating. However, in this example I've opted for the recommended 16 amp circuit breaker instead, which I've set to 10 amps to match the inverter input current of 9.2 amps. Both the fuses and breaker can be ordered from us. Search for order code 30049 for the fuse and 30016 for the breaker. But bear in mind that the fuse or breaker rating depends on the drive, so check the manual to identify the correct part number for your inverter rating. With the breaker installed, the output side can be connected to the EMC filter input terminals. The motor connection is a little more involved, as we need to ensure the cable screen is properly grounded for EMC compliance. Fortunately, WEG provide an EMC clamp plate to help us do this. I'm using standard SY cable, and you can see that I've exposed the cable screen so we can clamp it in place to get 360-degree coverage. I have also wired the earth cable to the clamp, and the 3 phases are connected to the terminals. They need to be cut to the correct length first, as space is tight. Don't forget that the CFW100 is an IP20 rated drive. This means that it offers no protection from dust, so must be installed in a suitable enclosure to protect it from contamination. Now to connect the motor. The motor we're using in this example is a WEG W22, but we can use any 3-phase induction motor provided the rating doesn't exceed that of the inverter. Strictly speaking, we should ensure the motor is inverter rated, but almost all modern motors are. The motor rating plate allows us to check the full load current and supply. This motor is dual rated for 400 volt 3-phase in star to 1.68 amps and 230 volt 3-phase in delta to 2.92 amps, both at 50 Hz. We know that this particular CFW100 is a 230 volt inverter capable of 4.2 amps, so 2.92 amps is well within its rating. However, we will need to ensure the motor is configured in delta, which means checking the links in the terminal box. Once the terminal box cover is removed, we can see that the links are arranged in star. This is a typical from the factory arrangement for motors of this size. To change the links to delta, remove all 6 nuts, then rearrange the links and refit the nuts furthest away from the cable entry point. We can now connect the earth and screen to the grounding point in the terminal box and the 3 phases from the inverter cable. Ensure all connections are nice and tight and refit the cover. Once the connections are made, and if it's safe to do so, power up the inverter. It will work with the motor straight out of the box, but we don't recommend you leave it this way. Before we start commissioning the inverter, I'll give you a quick overview of the operator keypad. There are 4 keys from left to right: P, which allows access to the parameter list and values, the down and up keys, which can be used to navigate the parameters and increase or decrease values, and the start-stop key, which will start and stop the motor or reset the inverter after a fault. The LCD display shows motor rotation on the top left, in this case clockwise. This needs to be checked to confirm that the indicated rotation is correct. We'll do this shortly. Also on the left-hand side are arrows which appear when up to 2 incompatible parameter settings are detected. These remain visible until the settings are corrected. On the right side, any applicable units are shown. These can be %, V for volts, A for amps, HZ for hertz, S for seconds, degrees Celsius, and RPM for revolutions per minute. The bulk of the display is taken up with a 4-digit 7-segment display which is capable of showing negative values for diagnostics and some parameters and decimal places in various positions. There is also a bar graph at the bottom of the screen which displays output current by default but can be customized to display different parameter values, but we'll cover this in another video. Okay, moving on to commissioning. If you make no other changes, you should at least set motor rated current. This allows the inverter to protect the motor if it's overloaded. To set this, ensure the motor is not running and press the P key to access the parameter list. Then use the up and down arrow keys to find parameter P401. Press the P key again to select it. The A, shown on the right-hand side of the screen, indicates that this parameter value is in amps. Now set the value to match the motor, which in this case is the 2.9 amps we checked earlier. Press the P key to save the changes and return to the parameter list. The motor rated speed can be set in P402, so press the up key to reach it, then the P key to edit. The value is in revolutions per minute, indicated as RPM on the right. In this case, we'll set it to 1430 RPM and press the P key to save. Next, we'll set P403, which is motor rated frequency. Press the up key to reach it, then the P key to edit. Again, this should be set to match the motor, so in this case 50 Hz. Press the P key to save. Next, we set the maximum output current and type of control. P135 is the maximum output current. This can be used to define an overload, which is the percentage the inverter will allow the motor to exceed its rating for a short period of time. By default, it's set to 150% of the inverter rating, but it should be changed to 150% of the motor rating if this is lower. If the inverter detects that the output current is above the value set in P135 during acceleration, it will hold the speed to bring the current under control before continuing to accelerate. If the speed is constant and the output current exceeds P135, the inverter will slow the motor to bring the current under control before accelerating back to the original speed. In this case, 150% of 2.92 amps is 4.38 amps, so we'll set P135 accordingly. The next parameter to consider is P202, which is the type of control. This defines a relationship between output volts and frequency. There are no units for this parameter, so no indication on the right. The default value is 0, which means the relationship will be linear, like this. This is suitable for what are called constant torque applications, something like a conveyor or hoist, where the torque demand from the load remains relatively constant. In these applications, the relationship between speed and power is linear, so a 20% increase in speed, for example from 40 Hz to 50 Hz, would typically require 20% more power. If your load is a fan or centrifugal pump, the torque demand is variable and will multiply with speed as more and more air or liquid is blown or pumped. This relationship is quadratic, with torque increasing as the square of speed. However, in this case, the power required increases as the cube of speed, so a 20% increase, again from 40 Hz to 50 Hz, will require twice the power. For these applications, P202 should be set to 1. So why am I going into this much detail? It's to highlight the significant difference between these two types of load and the importance of setting up the drive to suit. To recap, if your load is a fan or a pump, set P202 to 1. If not, set it to 0. There is one caveat to this, the third option. 5. Yes, I know, but 2 to 4 are not used on the CFW100. 5 is optional and sets the inverter to operate in VVW or sensorless vector control. It's a topic we'll explore in a later video. As we're not running a fan or a pump, I will return the parameter value to the default of 0 and save it. Okay, that's the motor data set. Now we can run the motor to check the direction of rotation. Before we do, I will set parameter P005 so we can see the output frequency in Hertz. Now press the Start-Stop button on the inverter to start the motor. The motor turns, but it's slow. This is because we haven't set a speed reference, so the inverter defaults to the minimum speed, which is 3 Hz. We'll learn how to change the speed and set minimum and maximum limits in the next video, but for now the slow speed is ideal to check rotation. We can see that the direction is counterclockwise, which is the opposite to the display, so it needs to be changed to match. This is easily done by swapping any two of the 3 motor phases at either the inverter or motor end. Don't forget to isolate the inverter before making any wiring changes. In this example, we'll swap the phases at the motor end. Simply unscrew the bolts and remove the cover to access the terminals inside, remove 2 of the nuts to free the cables, then simply swap the phases over. It doesn't matter which 2 are swapped, as the direction will be reversed regardless. Once the cables are swapped, each nut should be refitted securely. Note that many motors are fitted with a dust-tight gasket, so remember not to over-tighten the terminal cover bolt when replacing. Now when we restart the motor, the rotation will be clockwise. Let's try it out. Perfect. One last thing to demonstrate is what happens when the supply is removed. Initially something seems to be wrong. No power is going to the inverter, but it's clearly still on. This is because there is stored energy within the drive capacitors. As they discharge, the voltage drops below a preset level and the display shows sub before finally turning off. It's important to mention this as a voltage may be present during this period. So even after isolating the drive, you should wait until it's completely discharged before accessing any of the terminals. WEG recommend 10 minutes for this. Okay, that's it for part 1. Thanks for watching, and I hope you'll join me for part 2, where we'll learn how to increase and decrease speed, set maximum, minimum or a fixed speed, and change acceleration and deceleration rates and direction of rotation. If you found this video helpful, please give it a thumbs up and consider subscribing, as we really appreciate your support. See you next time.